Hi everyone. Today we're going to study shifts of the function f of x equals b raised to x. In some books it is written shifts of the parent function f of x equals b raised to x. For any constants c and d, the function f of x equals b raised to the sum x plus c, then plus d. Shifts the parent function f of x equals b raised to x. Vertically, d units in the same direction of the sign of d. It means if d is positive, it shifts up, while if d is negative, it shifts down. Horizontally, c units in the opposite direction of the sign of c. It means if c is negative, it shifts to the right, while if c is positive, it shifts to the left. The y-intercept becomes these coordinates 0, b raised to c plus d. The horizontal asymptote becomes y equals d. The range becomes this open interval d, positive infinity, while the domain, that is from negative infinity to positive infinity, remains unchanged. Let us see this example. Graph f of x equals 2 raised to the power x plus 1, then minus 3. State the domain, range, and asymptote. Our problem here is an exponential equation of the form f of x equals b raised to the power x plus c, then plus d. And we can see that the b is equal to 2. The c equals 1, and the d equals negative 3. We will draw the horizontal asymptote y equals d. So it means this is y equals negative 3. And then we will identify the shift as negative c, d. So the shift is negative 1, negative 3. So we will shift the graph of f of x equals 2 raised to x to the left 1 unit and down 3 units. This is now our beautiful graph. By the way, this red broken line is the horizontal asymptote. That is the y equals negative 3. Our y-intercept now becomes 0, negative 1. It comes from our quick formula 0, b raised to c plus d. We have here two more points of the graph, 1, 1 and negative 1, negative 2. The domain is from negative infinity to positive infinity. The range, negative 3, positive infinity. And the horizontal asymptote, that is the y equals negative 3. This is now the final answer. I hope you learned something from this video. See you again next time.